Okay, so this is the last review for kinematics. The position of an object is given by the equation position over time equals 2 plus 4t minus t squared. What is the particle's instantaneous velocity at 3 seconds? What is the particle's average velocity from t equals 0 to t equals 3 seconds? And what is the particle's average acceleration from t equals 0 to t equals 2 seconds? So let's look at part A. So we get position as a function of time is equal to 2 plus 4t minus t squared. Since we're looking for the velocity over here, the instantaneous velocity, what we have to do with this position as a function of time is we need to take the derivative of this. So when we take the derivative, velocity as a function of time is going to equal 0 plus 4 minus 2t. We want to find the velocity at 3 seconds. So what we're going to use velocity 3 equals 0 plus 4 minus 2. And in that 3, we're going to put that 3 right there. In that t, we're going to put that 3 right there. And what we get with this problem is the velocity at 3 seconds is going to be negative 2 meters per second. All right, let's go to part B. What is the particle's average velocity from t equals 0 to t equals 3? So we do position versus function of time. 2 plus 4t minus t squared. And since it's looking for velocity, you might automatically think, oh, I need to take the derivative of this. However, since we're looking for the average velocity over here, we're looking for how far does it go from 0 to 3 seconds, and then dividing by that 3 seconds. So we're going to find, or let's see how far it goes, how far it is at t equals 0 seconds first. So x0 is equal to 2 plus 4, 0 minus 0 squared. What you get is, this is 0, you get 2 meters. Let's see how far it goes at t equals 3 seconds. So we're going to x3 equals 2 plus 4, 3 minus 3 squared. And what you get over here is 5 meters. Now, when we're looking for the average velocity, we want to see how far it goes in these 3 seconds. So we know that what we're going to do is position final minus position initial over time is going to give us the average velocity. So we have a final position of 5, a starting position of 2, and this happened all in 3 seconds. So what we realize is the average velocity from this point to this point is 1 meter per second. And we realize that the average velocity and the instantaneous velocity are different numbers. Let's go to part C. Okay, so what is a particle's average acceleration from t equals 0 to t equals 2 seconds? There's 2 main ways to do this one over here. Let's see, xt equals to be position as a function of time is 2 plus 4t minus t squared. Let's find a derivative of this. Velocity as a function of time is equal to be 0 plus 4 minus 2t over here. And so we can do it this way first. So what is the particle's average acceleration from t equals 0 to t equals 2? So we're going to be looking at this formula right here. V final minus V initial over t. And this will give us the acceleration. So for the first one, let's look at t0. The velocity at time equals 0. Because it would be 0 plus 4 minus 2, 0. And what you get is 4 meters per second. And then let's find what the velocity is at 2 seconds. What you get is 0 plus 4 minus 2, and then 2 over here. Then what you get over here is 0 meters per second. Let's plug this in over here. V final, we found that the final velocity is 0. Initial velocity is minus 4. Time from 0 to 2, 2 seconds. And what you get is negative 2 meters per second squared. Another way of doing this problem is, so let's ignore this for now. So I'm just put an X over here. Let's ignore that. We found the velocity as a function of time, and what we're going to do is let's find the derivative of this, which gives us the acceleration as a function of time, and that's going to give us 0 plus 0 minus 2. And what we realize is the acceleration as a function of time is going to equal negative 2 meters per second squared, no matter what the time is. The time could be 0, the time could be 2, the time could be 10, 1,000. It's always going to be, the acceleration in this case is always going to be negative 2 meters per second squared. So in this situation, when I ask what's the average acceleration, it's always going negative 2 meters per second squared. So we can find it this way to be negative 2 meters per second squared as well. Alright, thank you.